Welcome to Ask and Learn.
In this problem, we have a box that slides down a frictionless ramp and then onto some cart, which then collides to another block. So we want to find the distance that the second block travels after the collision. So we're given information for the first block. So we have its weight, which is 30 pounds. And we can convert that to mass by dividing by 32.2 feet per second. So for mass for this block, we get 0.93 kilograms. We also know this block experiences kinetic friction when it slides on the cart, and so we're given the coefficient of kinetic friction is 0.6. So the weight of the block is causing a work because it travels a certain distance, and we know we can use the work energy principle, which is just initial kinetic energy plus the work being done by the forces will equal the final kinetic energy. But we're told that initially this block at the top of the ramp starts at rest, so the initial kinetic energy is 0. And we want to know, and we also know that after the collision, the block stops moving, so its final kinetic energy is also 0. So all we're left with is the work being done by the forces equals 0. So the only forces involved in this problem is the weight due to the block that's sliding down the ramp, and then the frictional force when it's sliding on the cart. So we know that work is equal to force times distance. For the first one, for the weight, we have the weight of the block times the horizontal distance it travels, which we'll call Sy, and we know that to be 4, and then minus the work being done by the frictional force, and that's in the opposite direction, so that's how we have a negative here. So the frictional force, the equation is mu k, coefficient of kinetic friction, times the normal force Fn times some distance S. And the next thing we need to find is Fn, and we know if we draw a free body diagram of the block, we know that the pointing down is the weight of the block and straight up is Fn. So Fn is just, again, the weight. So if we plug it in, we have W times the horizontal distance Sy minus UK times W times some distance it travels is equal to 0. So now let's move this part to the right. So we have W times Sy is equal to UK W times S. So we're solving for S. So we know that the W's cancel. Makes our equation a lot simpler. So we have S. If we isolate it, we divide mu k to both sides. So S is equal to Sy divided by mu k. Plugging in our numbers, Sy is 4, mu k is 0.6. So S is equal to 6.67. And this is the distance the block travels right before it hits the second block. So that means the final distance that the second block will travel, SF, will be that total distance of the cart, which is 10 feet, minus the distance we just found, 6.67. So we have for S final 3.33 feet.